It's time. All right, guys, it's time. All right, this is the Netconf working group meeting. If you're not already familiar with the Notewell, please go through it. There's a link also at the bottom of the slide. All right, so blue sheets have been passed out. Make sure that you do put your name down on the blue sheets. At the mic, make sure you do pronounce your name slowly for people who are trying to take notes in Etherpad, which we'll come to in a minute. Pose all your questions at the microphone itself so that remote participants can listen to the question. The chairs at least have their own JavaScripts, but if anyone else wants to take lead on it, I'd be happy to have someone be the JavaScript. Okay, I guess the chairs would then will act as the scribes. We do have Etherpad, so anyone sitting in the room can use that link at the bottom of the slide to contribute to the meetings page. Just to let you know that we also rely on the transcribing of the meeting, the voice recording of the meeting to actually take notes and update the minutes. There's been at least one draft that was published since the last Netconf meeting. So congratulations to the authors and to the work group. So as far as the status of chartered items, the Yang Push suite of drafts, there are at least 4 of them. They have passed IESG and are in the RFC editor queue already. In fact, the RFC editor has been through most of the changes. We expect it to be in AUT48 state pretty soon for the final review before they are published as RFCs. In the meeting today, we expect the client-server suite of drafts to be presented. So that's work in progress. Yang push notification capabilities is also being presented today. We'll discuss the status of that draft. We haven't had a request for presentation of the Yang push notification messages draft, so, but we still see that to be work in progress. As far as the agenda is concerned, it's already published in the agenda on the IETF website. All of these are chartered items except for the last item, which is still an individual draft. The other item left on the chartered item is, of course, the notification capabilities, which will be, as I said, presented today. And I think maybe it's capability 02, I don't know. In the non-chartered items, we still have the multiple streams originator draft and the new draft, which is the HTTPS-based transport for configured subscriptions. So that's any questions related either to the slides, these slides, or the agenda items.
Balázs Lengyel Erickson. I would like to ask what's the situation with some of the other Yang push related slides, like the UDP encoding, there was the binary encoding, or UNIP transport, the binary encoding, call home that was provisionally taken out from the Yang push.
So there was a draft called UDP pub sub, is that the one you're referring to? That was a working group adopted draft, but we unadopted it last time because the main focus was actually the multi-stream originator. What that draft needs to do is to be brought to the working groups again as a notif draft. So something like UDP notif, so someone can resubmit it in that fashion, then it could be accepted by the working group. Does that make sense?
Sorry, could you speak that on the mic?
It says on the website it's still adopted.
So on the status page, UDP pub sub is still in the working group.
Okay, we'll take a look at that. Yep. We did ask the Secretariat to remove it for us, but we'll check on that.
And the binary encoding and call home?
The binary encoding, so
that's still an individual draft. It's not a work group item draft. If you're referring to the draft that I presented a couple of Netconf. Yeah, so it's still there. It may need a revision, but it's an individual draft at this point.
And the call home parts that we took out from Yang push, is there any development on that, or?
So the call home parts, I think if you look to the draft that Mahesh is presenting, it's the last one on the list here. It's actually presenting a notif transport for configured subscriptions, which does in fact do call home. Well, in that case, we shouldn't say call home. Let's just say device initiated connection.
And okay.
Hi, this is Hank. I will join in Ken's presentation later, and in that context, I want to highlight that there could also be a co-app call home, because in the context we will present here. So I was going to highlight there could be multiple variants of doing this, and I'm not sure if they should be in across documents or in a single document. I really don't know.
So Hank is saying that there's another effort for doing a binary transport, a binary notif transport for notifications.
You can start with the presentations.
Okay, hi, good morning. So we're going to be presenting the suite of the client-server drafts. And of course, as Mahesh just said, all but one has been adopted working group item. The last one, the HTTP client-server, we did attempt to run it, the adoption the same time we did the TCP client-server adoption. There was some pushback from the HTTP biz chairs, which honestly we didn't have the energy at that time to pursue. And, because the focus, actually, let me move to the next slide. The focus is on the first three drafts that we're trying to get them into working group last call as quickly as possible. So, after those have actually achieved last call status, then the focus will shift again to trying to get the remaining hierarchy of drafts adopted and published. So that's when you should look to seeing the HTTP client server draft adopted. And let me just quickly see. Yes, okay, so this presentation's focus is threefold. There's the crypto types draft, which we'll spend actually most of our time on, I think. Then there's the key store draft, and lastly, the RESTconf server draft. But so this presentation actually just touches on, if you go back to that previous list, it really just touches on 3 out of, how many are we looking at? 9 drafts. And in particular, it doesn't talk about, Hank, the trust anchors draft, which I think we were discussing yesterday. You wanted to ask a question about, so maybe now would be a good time to ask your question about the trust anchors draft, and especially how it relates to the TLS draft.
Yeah, exactly. So this is Hank again. So this is my so officially it's a core hat. It's probably also a Yang of Things hat on. All of these people try to do binary Yang. There is CoreConf coming up, formerly known as COMI, and this is using DTLS if it's secured, of course, and it should be, and it will be, and CoAP. And on the DTLS level, CoAP advises to use different securing ways to secure CoAP, and that is a public raw key, a raw public key, also in a minimal CMS frame, as it was standardized years ago. And also we have this concept of pairwise symmetric keys that are pre-provisioned, and both of these are suggested methods to secure CoAP by the CoAP RFC, and they can be applied to two levels. They can be applied to DTLS, and therefore would extend into TLS, which is effectively also done today. I mean, a lot of people use PSKs, probably known as pre-shared keys. We like the term pairwise symmetric key. And the raw public key, of course, is a little bit different than the SSH key material. So my proposal here and this mic is to add these two flavors, like the raw public key and the pairwise symmetric key, to the trust store draft. And Ken and I were already talking about this. So we are aligned, but the room has to be fine with this, because this extends a little bit into TLS, into DTLS. It is mandated by CoAP and could be used not also on the communication layer, but also on the application. So on the object security layer. So it's a communication security, and it can also be an object security. So it also goes back into OSCORE, the object security for constrained environment. So there are multiple consumers of this information, and my personal point of view is we should add that to the draft itself.
Okay, great, thank you. And actually, to add to that, even with the TLS draft, the TLS itself, we primarily think about certificates, but it does support other forms like PGP and pre-shared keys. And currently, Trust Anchor draft does not have any support at all for these things. It's really an omission that we ourselves should have caught before, and I would expect ISG would have if we had taken those drafts last call. So what Hank is raising right now, in the context of DTLS, actually, we already had an issue with the TLS draft, and so extending the Trust Anchors draft to support pre-share keys and what was the other thing? Oh, raw keys would be the proper thing to do. And we have another comment coming to the mic.
Tim Carinoki, I do have a question on this approach, though, because there's going to be many consumers of these particular drafts, hopefully, right, outside the context of just client server type of stuff. So here we have an example of COMI and CoAP wanting to augment, and I use that word I think appropriately here, some of the work that's happening in the key store, from a different area. So is it the approach or strategy to continually revising these drafts so that is the universal crypto or key store types that we want to deal with, or do we expect the other working groups to use those drafts and incorporate them into their work? And so I'm just trying to understand, the difference, because otherwise we'll be revving this thing for, every use possible, and that's
right.
If I can quickly interject, so there is a sector review of the set of drafts sometime later today or maybe tomorrow, and we're looking for proposals from them to tell us whether the approach that we're taking allows for extensibility, if need be, without necessarily revising these set of drafts continuously. So at least if the framework of these drafts looks good enough, then other working groups can extend the models.
This is Henke again, and addressing the concern of perpetual churn. We don't want that. So it's basically still the same scope, but I think it was more like an oversight on the DTLS part. So we are not moving outside TLS and SSH here. So the requirements are coming from the same document. So we actually have the same scope, but we are now complete in that scope, I think. And beyond that, it should be different drafts or someone else augmenting us.
Okay, so what I understand what you're saying, Hank, is that the base, what we would consider to be any base draft that would come out of NetMod would incorporate both SSH, TLS, and DTLS implementations, and that we kind of missed the DTLS, and that we're agreeing as a working group that DTLS is a core secure transport for the IETF, for the work that we do, right?
Okay, so I don't know which hat I'm using at the moment, but this working group is primarily focused on Netconf and RESTconf, and they only have SSH and TLS as being official transport bindings, not CoAP yet. Sorry, Hank. And that's why I mentioned that even though TLS itself actually already has the need to support pre-shared keys and raw keys, it's in the TLS draft. So our support of TLS for our own purposes is already incomplete. And so that's what I'm really
saying. So you're
saying.
saying it's not a DTLS thing, it's a TLS thing.
It's a TLS thing. It's incomplete. Hank raised it. It's actually absolutely correct. It would have been caught by ISG had we tried to take the last call. But it's better this way that we can, while the focus is on Trust Anchor, getting it to last call.
But we would expect Core to take, if they want to use this for DTLS, we would and do anything different, right? We would expect Core to take and augment
I think,
something.
after Trust Anchors has been published, if any other group wanted to extend it and add another kind of Trust Anchor, then it would be a proper augmentation, a Yang augmentation, and it would proceed that way.
It was basically a lucky coincidence that this is not exceeding your scope.
Okay, good. Okay, very good. All right, so before I move to the next slide and kind of get into it again, these first three drafts that we're focusing on trying to get to last call, cryptotypes, which we're going to spend quite some time discussing today, is probably the one that's going to take the longest to resolve. Trust Anchors, I thought, was resolved, but per the discussion we just had, is now needing to be extended slightly. I actually don't view this as to be terribly complicated and will likely conclude before the cryptotypes discussion concludes. And then lastly, there's the key store, which is also on today's discussion, but thankfully I think we're at the end of the tunnel and it is going to move forward quickly. Okay, so back to this slide again. And I'll just move on then, I think. So let's begin the first discussion about cryptotypes and algorithm identity strategy. I'd like to invite my co-authors, Michael and Frank. Sorry, Hawang and Frank? Oh, just Hawang. Okay, great. All right, so first let me do the setup and then I'll transfer. Okay, so the high-level decision that we're needing to make right now is whether or not we stay the course or simplify. The current approach with cryptotypes is to unify all the algorithms produced by disconnected security area efforts. So there's lots of working groups within the security area, and each of them are defining crypto algorithms that are effectively the identical kinds of things, but they give them different names, and they create different IANA registries having different numbers, assigned numbers to them, which is, convenient because, each is in their own protocol. But here we're trying to define a unified layer, this key store layer. It needs to store keys that can be used by any protocol. So we get ourselves into this problem space where we're trying to unify the set of, algorithms, identities or enumerations or whatever we're using that can span the gamut of all these different protocols. So that's the fundamental problem that we're dealing with right now. Solving this problem is the right thing to do, but it's difficult. And as Mahesh just mentioned a moment ago, last week, the chairs did request an early sector review. We were, Rafet was assigned and we had a call with him last week. And then just, I heard over email that the topic was raised in the ISG discussion on Sunday. And now someone, Michelle from IANA has been asked to have a meeting with Rafet and the chairs, in order to try to discuss what the next step is to do. So there is some progress on that front in terms of what is the right thing to do. But before, sorry, and I think maybe Ignas, did you want to say something about that?
Ignas Bagdonas, Equinix. Yes, this was discussed briefly at a G-Sunday meeting, and the outcome of that is that there is no outcome at this time.
Right.
And what is needed is that probably this working group needs to think of what of the proposed options. Either we don't have a registry, but put hard-coded values into the documents and respin that every time. Have a unified registry, which is on the IANA side, or have something in between. This is something for probably Netconf here to think about that and provide a recommendation what you would see. What would be the, say, more stable in the longer term?
Right. Okay, perfect. And that's the setup for the last line here. The authors wish to see this approach play out. Again, it is the right thing to do, but we're beginning to think about fallback strategies. So this discussion, number one here, is to first try to talk about what is the, how we can, the current approach, the right thing to do, and what we can do to make it complete and solved. Then there's a discussion about a possible fallback strategy. And then actually, again, in my conversation with Hank yesterday during hackathon, there's a possible third approach that we could consider as well, which I'll discuss at that time. Okay, so then now I think I'll pass it to my co-author.
Yeah, good morning, everyone. My name is Hai Guang from Huawei. I'm co-author of this IETF draft crypto type algorithm. I mainly help in this crypto algorithm identifiers. So in this slide, I will give some background on the crypto type crypto algorithm identifiers. Yeah, initially we use identity to identify each security algorithm, like the upper in the upper figure. Yeah, for each security algorithm, we give a name and we give a description and so on. We classify them into a few categories. For example, we have a hash algorithm and symmetric encryption algorithm and asymmetric so on. Also key exchange. But later, actually, some experts from I2NSF they have some suggestion that maybe enumerate type could be better because it is simple to management, and also when new algorithm is designed, we can simply add a single value in the INA and RPC from different group can refer to the value in the protocol definition. So after that, in the recent draft, we changed to the new style of, in the enumerate format, and for each crypto algorithm, there's a value field to identify this algorithm. Yeah, for details can be looked into can refer to the draft 10. So based on my contribution on this crypto algorithm, actually I have some personal observation over the crypto algorithm used in the IETF. There are many RPCs that use different security algorithms, including various public and symmetric, and also the hash, like in the TLS, IPsec, and I2NSF. So many RPC has been published, and many crypto algorithms have been defined and registered to the INA. The figure below shows the algorithm from two groups. One is TLS, one is from SSH. So different group and different RPC has their own style in different defining crypto algorithm. For example, even for the TLS 1.2 and 1.3, the definition is different. So this brings a lot of effort for the RPC editor designers has to define, review, implement, and manage the algorithm. So eventually they are going to be used in a real system. So I think there are lots of additional maintenance work has to be done there also. So based on this observation, I have some open questions. Yeah, should we come up with a unified framework? For example, a unified list or any page for crypto algorithm identifiers so that they can be shared among different groups and RPCs. For example, we can classify the crypto algorithm into a few category and assign a unique number to each of them. And so other RPCs in the future can refer to this this list and do not need to specify the algorithm identifiers by themselves. Just a simple reference. Yeah, this is what I'm thinking based on my observation. So if there are better methods, so we can put it on mailing list. So we can even, for example, later put in the crypto type draft. Yeah. So that's what I want to share. Yeah, thank you.
Okay, and don't go away just yet. So and speaking of better methods, this is what I was saying in my discussion with Hank. You were talking about Cozy and how when this is the encryption of JSON documents, right? And when that draft became RFC, it registered a bunch of IANA registries, is it? Actually, IANA registries, and they cover a large number of cryptographic algorithms. I think your proposal was that we might be able to leverage that work.
Yeah, this is Hank again. It's for Cozy, for the CBOR variation. But Jimshad is the expert on this registry, and all the groups there, all the other participants there in the group did an awesome job. It's key parameters, it's curves, it's hashing, it's signatures, it's crypto, and it's always in combination. Not only the not only the basics, but the combination of key strength and yada yada. So it's a very elaborate IANA registry already there. And it's pretty much, I don't want to say complete, but it's very, very detailed already. So this could be another well-maintained source for everything crypto algo. I'm not saying that it is complete for your scope, because it prunes some of the very old stuff and, of course, of the deprecated things, but it's the best maintained IANA table I know, actually. So maybe, yeah.
Something to look at.
Frank Xiaohui. I have an interest and a general question about this kind of thing. Hank, you have mentioned that for the Cozy, for this technology, we have a very complete crypto algorithm IANA page, right? So, what is the relation with this new IANA page and with the existing IANA page for the TLS, for IPsec and SSH? And what is your future plan of how to align with them? This is a very important problem.
Yes, this is Hank again. This is not resolved yet. So we have either the option to choose in the module where to go to, but this can be very confusing, and it would require a lot of implementation and complexity. So that seems to be a bad idea. But if there are gaps, and if you see maybe an assessment of the tables is in order, you're TLS based, so basically that's the way to go. You cannot do something wrong there, I think. From the Yang of things point of view, we could just augment that and so if you have an extension point, that it's good to augment. So the Yang of things RAM could do that just and live with that, and that's okay. I just wanted to highlight that there's another table. So, and it's well maintained, and it goes beyond what TLS does, but it might not be complete because I have not made a one-to-one comparison of those actually. So this is just the first discussion about this.
My personal comment is that it's not the responsibility of the individual or working group drafter to maintain or to reflect the latest upgrade of the crypto algorithm. I hope that those inner pages can be aligned with each other, and they take care of this kind of thing, and we just reference to them. I think that's the best way for not only for our draft, maybe for future another draft, right? The inner should take care of all this kind of thing. So maybe Hank and other guys, you will still maintain this kind of, right?
Okay, great. Well, you're right. So this is definitely a good resource for us to look at, and in terms of potentially using, folding some of those ideas into what we're trying to achieve with this approach. And to Frank's very last comment, exactly. I think that currently the CryptoTypes draft defines one IETF module, and really we should be thinking about breaking it up to many IANA modules. So, this is, of course, assuming we stay the course with this approach. But, twofold. First, assigning to IANA allows IANA to update the modules outside the standard RFC cycle. I think this is important, and probably what Frank was just saying. Although there may be some disagreement as to the extent that IANA will actually be updating the modules outside but we need to figure that out. But that would be the intent, is to allow them to be able to make those updates. So as and when any security area group defines an extension, a new protocol, a new addition to a registry, automatically the Yang module would be updated and published by IANA, not us. Secondly, breaking it up into many modules enables each to have a better focus. So it's unclear to me actually how important this particular point might be, but it does seem like it would be favorable to especially IANA if they were being asked to maintain them. Yes, question?
Rob Wilson, Cisco. Why would you split it to many IANA modules? I'm missing that step as to why it goes from one to many.
Okay, that was the second bullet point. So again, it's unclear to me how important it may be, but to myself, programmatically it doesn't matter. But from a maintenance perspective, especially if you're asking IANA to do the maintenance, it could be helpful to them that then it's been broken up to many modules. In either case, it'd still be one draft. So this draft, the CryptoTypes draft, would continue to be the draft that would, create all these if there were many modules, it'd still be one draft that defines all the modules and assigns them to the IANA.
And so those modules, are they representing what the different security working groups are producing in terms of what's the
exactly.
finding?
So there'd be, for instance, a module that would be for symmetric key algorithms, another module for asymmetric key algorithms, another module for hashing algorithms. Okay. If it makes sense to do this, to break it up that way.
Yeah, it makes sense.
Okay. All right. So so we would continue using this draft. Okay. So the fallback strategy. This is, in case we don't stay the course and we wish to simplify. And I did post this to the mailing list. There was no response, but so here we are going to go over it. The general idea is to admit that TLS is the transport layer for most protocols, right? I mean, in reality, on the network. And imagine us, aligning ourselves to a more TLS-oriented solution. A TLS protocol is heavily defined using ASN.1 structures, right? If you look to RFC 5280, you'll see nothing but ASN.1 in there. Which is how you then wind up with things like PIM, well, not PIM, but DIR encoding and BER encoding, in particular, or even PIM. They're all effectively encodings of ASN.1 structures. Already, CryptoTypes draft defines many ASN.1 types. So there are types for, in particular, CMS structures. So signed data, encrypted data, and just plain CMS. There's actually 6 or 7 CMS types that are defined there. 3 of them, I think, are used directly by the zero-touch draft. And, of course, having them, in the CryptoTypes draft. So actually, zero-touch copy-pasted. It's the same text, but to get zero-touch out the door, it didn't actually have a normative reference to CryptoTypes. It's just so anyway, it's the same idea. It would be valuable for the CryptoTypes draft to have those ASN.1 types defined in it. So why not add one more ASN.1 type to it. In particular, RFC 5958 defines what they call one asymmetric key. It's a strange name, I know, but the title of that draft is Asymmetric Key Packages. And if you look there at the ASN.1 at the bottom of the screen, you'll notice that it has private key algorithm identifier, right? And so already they've somehow solved the problem of all the different identifiers that can be used and how to refer to them when encoding ASN.1 structures. So yeah, exactly. Notice this private key identifier. If you dig a little bit deeper, you'll see private key identifier is an algorithm identifier. And if you dig into that, you'll see that this algorithm is identified by an object, an OID. And then you try to figure out what that is, and you don't quite. I think that ultimately maps to an IANA registry. I tried to find it, I couldn't find it, so I kind of bottomed out at that point. But you get the idea. They've tried to solve. They have solved, right? Because it's running code. We just need to figure out how it's being done. But then what is an OpenSSL private key? And I as I think some of you know, I've written to the list. I'm in the process of implementing a RESTconf server, and it does implement this. It does use IETF RESTconf server, which means the entire hierarchy and down to key store and trust store and all this. And I'm trying to write code, and the simplest thing for me to do is use OpenSSL. You can see the first command there, EC param. I want to generate a private key. And then from that, I want to, generate the public key. I'm basically executing OpenSSL command line, utility command line commands to create these things for me. And then, of course, I create the certificate signing request and sign the certificate, and all that goes into trust store. But what am I doing? What am I putting in the key store, right? So currently, we don't have a well-defined solution, and I'm kind of just getting something to work. And so I hack it, and I just basically put the base64 encoded whatever OpenSSL outputted, and that I stuck into the key store. I'm a lazy programmer. This is easy. Everyone would probably be wanting to do this also. It's very simple. So, that's the question. So what is this thing that OpenSSL is outputting? Is it in one asymmetric key? I tried to get a better parsing. That's what OpenSSL gave me, but I can't quite see if that's a one asymmetric key. It doesn't print out the OIDs. So that, regardless, whatever OpenSSL is using would be convenient for us to adopt, even if it's not the one asymmetric key. So here's something, or find a simple way to convert between the two. That's what we need to do. Okay, so that's the end of that discussion, but somehow I feel, are there any questions? Did anybody have any questions about this? I guess maybe I kind of skimmed over the fact where no one raised their hand. What do you mean we're only going to support TLS? What about SSH? SSH is important, right? I mean, Netconf has a mandatory transport. Somebody was going to ask that question, right? I can see people nodding their heads. Yes, SSH is important. So I don't know exactly what we would do for, of course we'd want to support it, but maybe the SSH client server draft, well, we'll just have to figure it out. I mean, I'm sure there's a way of getting to it. Maybe it's a choice, and then inside the choice, it's what one asymmetric key is the one option of the choice, and the other option of the choice is something we make up that's very SSH oriented and supports SSH. So we'd find a way to carry forward SSH support, but primarily the intent would be that we were focusing on TLS. Okay, does that make sense? Okay, that's the end of discussion one. No more questions. Thank you.
Second, everyone.
Okay. All right. So second discussion was regarding the key store draft, and in particular, there's long discussion. I'm sure everyone was privy to between Martin and others on device-generated keys and the hidden keys. So to be clear, with KeyStore, the goal is to enable manufacturers to ship devices with IDEV-ID certificates, or any, cryptographically secure identifying certificate. IDEV-ID is just a particular one, but any. This implies that the associated private keys are hidden, because if you're shipping a device with a forever certificate, you need that private key to be forever. And if it were ever exposed, it'd be disastrous, effectively. So generating and storing and protecting those keys inside cryptographic hardware like a TPM would effectively become mandatory for companies who wanted to ship their devices with IDEV certificates. So that's one goal. So having this ability to support devices shipped from manufacturing with key stores that have values in the operational data store that contain private key and associated certificate for IDEV certificates. Secondly, is to enable devices to generate keys. Again, this is a best practice. Generally, you don't want, many people do create private keys and then upload them to a device, but best practice is you ask the device to create the private key for you, and hence the private key itself never left the device. It's not on your file system. It's not in your memory. It's nowhere for a hacker to get to it, unless, of course, they go to the device itself. 3 is to enable clients to install subsequently hidden keys. So even though you want the device to generate keys, sometimes it has to be the case that you generate keys outside. But once you load them onto the device, you want them to be treated as effectively hidden, protected, so that they can never be discovered or figured out from that point forward. And some people might claim, oh, you can use NACM for this. Have it so that only the root user, the restore session user, can access that key. But even then, it's not quite what's being asked for here when people ask for these forever hidden keys. 4 is to support standard backup and restore interactions. So to the greatest extent possible, we want keys that are being created or loaded or hidden or whatever to be part of config. We want it to be the case that you can do copy config, get your configuration, and then if you need an RMA a device, you can do another copy config or edit config and put it onto the new device, and it's there. So this, so we want to support standard backup and restore interactions. The implicit statement here is that these hidden keys they need to be in config. Even though they're hidden, they need to be in config. And the sort of the punchline here is they need to be encrypted. So they're in config, but they're encrypted. So that's what we're getting to. And then 5, don't have keys in running with values only in operational. So this is like some people are talking about if you have a key that's in operational, but you want to use it in configuration, just create a proxy in configuration that has the name, for instance, a handle to it, but the rest of it is missing. This is kind of problematic from the Gang module design perspective because whether or not the key values are mandatory true versus mandatory false. There's lots of great properties that you get if the values are always mandatory true. Okay, so several strategies have been tried. You've probably noticed that we published the full suite of client-server drafts 3 times since IETF, the last IETF. The first, we tried having action statements that created values in operational, which had benefits of generally following the rule about how actions create values or are executed in the context of operational data store. But the cons were that you needed to copy the values into running in a way that was really complicated, and it never was really nice, user-friendly. Then we switched to an approach where we were trying to encode crypt hash-like values into the configuration. This had the benefit of all the values were in running, but the downside is that then we were encoding verbs into the values. So the values themselves encoded like a verb requesting the device to actually generate the key, which was considered unacceptable. And then lastly, we went with this, I'm calling it disconnected RPCs, but I only mean to say that they have no data store effect. Like you execute the RPC, it returns an output value, but it itself has no effect on any data store, not operational, not config, nothing. Instead, the client that receives the output needs to round trip and return back to the device the generated key to wherever it wanted that key to be located. So the pro is that it satisfies all the use cases, it seems, and especially when you include the fact that the output can be encrypted, that's the main thing. But the con is that round trip I just mentioned. Nonetheless, number 3 appears to have traction, and I just want to go into that just a bit more, just so everyone is clear. So in cryptotypes, we have grouping, So again, this is a cryptotypes, the previous draft we were talking about. We have two groupings, symmetric key and asymmetric key. And notice that there's a choice key type, and it has two leafs. One is just simply key binary. That would be your cipher text, your clear text key. So the actual key values themselves are raw and visible. And then there's another type, hidden key, which is of type empty. So it's just an empty value. And then now in key store draft, we have some groupings. So we start with, on the left-hand side, key reference type grouping, which is, we have this choice of two different kinds of key types. Are you referencing a symmetric key or an asymmetric key? We have encrypted value grouping. So here we're using the previous grouping, but now we're adding to it that there's a value that's a binary value. And then we have symmetric key grouping, which is using that grouping from cryptotypes, the one that was on the previous slide, and it's augmenting in a new kind of key type. So where before there was regular key and hidden key, now there's a new thing called encrypted key. And encrypted key is something that's using that encrypted key value, right? So the key, so what's happening is that there's a value, so there's a binary string, and there's a leaf that's referring to the other key that it was encrypted by. And then, of course, we do the same thing for asymmetric key store. And then lastly, there's two RPCs, one for generating a symmetric and asymmetric key. They're identical except for basic names. In the input, you can pass optionally an encrypted with parameter. So you can ask the device, yes, generate a key for me with said algorithm properties. But when you return it to me, encrypt the output value using this other key that's already in the key store. And I'm referring to it. And then you get back an encrypted key. From the actual data model perspective, you can see, I'll just go through one of these, but they're effectively the same. Asymmetric keys, and now you can see there's the private key, and there's these three types, the private key, hidden private key, and encrypted private key, right? And then underneath encrypted private key, there's that leaf ref to another value in the key store, and of course the ciphertext value of the encrypted key. So how does this work in an example? So you start, at the top we have TPM protected key. So this would be a key, if you look on the left-hand side, a special key shipped with the device used to encrypt the operator's key. So let's jump to the bottom. We have a symmetric key, which is the operator's encrypted key. So this would be a special key used to encrypt all other keys installed by the operator's crypto officer, right? So every operator might have a secret symmetric key that only its crypto officer knows. And anytime they want to bring up a new device, they encrypt that symmetric key using the device-specific asymmetric key, the one stored in the TPM. And then lastly, in the middle there, you have a generic key, which could be any key that might be used by TLS or SSH or any other. That key has then been encrypted by the operator's key. So this satisfies the goals that we showed before. Enabling manufacturers to ship devices with their certificates. So now we have both of those. They're in operational, but also they could be in factory default. There's another draft going through NetMod about a new factory default data store. So absolutely, they could be in factory default as well. And the private key is being reported with value hidden and an empty type. So this satisfies that goal. Enable devices to generate keys. So now we have this RPC to generate the keys, and the client can decide whether or not the key is encrypted. Enable clients to install subsequently hidden keys. So here the client can set, using, for instance, edit config, an encrypted key, but so it's actually not hidden. I mean, the use case, the goal is that they're hidden. It's not actually hidden. It's better than hidden. It's encrypted, and it's in configuration. So it's still in configuration, which means it can support backup and restore interactions, which is number 4. So all keys except for hidden keys, the truly hidden keys, the ones that were shipped from manufacturing, are in fact reported in configuration. So you do a get config and you get them. And of course, the RMA procedure can migrate the operator-wide key and then all the other keys that were used in the 99% of the configuration are then migrated to the new device. And then 5, we don't have keys in running with values that are only in operational. So that awkward idiom that we have of currently all the keys are mandatory true. And then we do have an open issue related to that though. So reporting all key values in factory default and running should the algorithm or public key nodes be suppressed. So this, I say it's an open issue because Martin, who I don't think is on the online, raised this, or continues to raise this as a potential concern. So that's why I'm trying to address it. Personally, I think that it's better for those values to be there because the pros are that the Yang model is best stating that all the fields are mandatory true. We tried the mandatory false approach before. It got really complicated, and I didn't see any value to it. Furthermore, there's no harm in reporting these values. The public key is public. It's okay if people see it. You can report it. The cons is that the values only have to be reported in operational, so it's unnecessary. So I admit, technically speaking, they don't have to be reported. So we're having something more than necessary. And then also Martin points out, it seems like special case handling. That's true, but I don't think this is really an issue. And the reason why is because I actually think this is something that needs to be embraced. So firstly, number one, it's already the case. The server has to have, quote, special handling for the hidden key type. So there really is no such thing as hidden key. There's actually a value, a real value in operational. Already the devices have to have special handling to understand this notion of a hidden key. So I don't actually, for instance, when you're doing an edit config and there's a value of hidden key, when the device is actually trying to commit the config, we're not actually telling it to delete the algorithm and public key. Like if the algorithm public keys were missing and we're only passing hidden key, we're not actually telling it delete the algorithm public key. You can't do that. It'd be illegal. So already there's special case handling that's going on. And so I think there's asking it to don't actually modify. So if we were to pass the algorithm public key and instead the special case handling is don't actually modify in case the client tried to change the values, don't actually try to change the values. That wouldn't make sense. Instead, throw an error. I think it's just special case handling of a different kind. So I don't see that as a bad thing. And then number two, I actually think it'd be better to define an annotation of some sort, metadata, that could be used generically to identify nodes that are effectively read-only. I think that such a annotation could be used in many other use cases outside of this use case. And in particular, if you think about schema mount, where you might have some data it's in the host system, but it's been shared to a virtual system. Effectively, that data is read-only in the context of the virtual system. So when the virtual system, if you do a get config on the virtual system, you get the value, but you don't. Currently, it's not flagged in a way that indicates that value is effectively read-only in the context of the virtual system. So something like an annotation that could flag this algorithm and a public key and even hidden key, those three values as basically being read-only would be perfect for this use case. So we could embrace and extend this idea to support that as well. Open issues continued. RMA requires a special new step. I spoke to this just a moment ago, but going just a level deeper. Assuming operators follow what would be effectively become best practice, which would be to create this operator-wide symmetric key that's encrypted on each device using the device's hidden key, and subsequently used to encrypt all the other keys. That's what we'd effectively be saying is new best practice. All operators should try to follow that approach if possible. Then the RMA process would change from what currently is today, load the config from the old device, and then do whatever additional customizations are necessary, such as installing any node lock licenses. And then actually, probably that might be out of order. You might actually have to install node lock licenses before you try to load the config on some devices. So that would change just a little bit to a new approach, which would be to manually install the encrypted operator-wide key on the new device, and then edit the config from the old device. So you did a get config from the old device, edit it just a little bit to delete the operator-wide key value that was there in the key store. Just delete it. And then save it, and then let that be the resulting file that you load onto the new device. That's number three, load it onto the new device, and then lastly, do these additional customizations, such as installing your node lock license keys. I think that's it for this discussion. Are there any comments about this? Again, this key store draft, I think we're at the end of the tunnel, hopefully.
Rob Wilton Cisco, is it safe to have a single operator-wide symmetric key? I mean, is that good security practice? In the sense of, if that key gets compromised, do you then effectively compromise all devices? And if so, would this scheme still work if, rather than having a single operator-wide symmetric key, they were managing separate keys for each device? So when you RMA it, you use whatever the key is identifying that.
Sure, you're right. It could be the case that it's a per device symmetric key, not operator wide. You're right. It could be. It'd just be more maintenance. Each operator would have to remember what was the symmetric key I used before. But yeah, it could be done.
So that's their choice, though.
That's their choice. And again, I mentioned crypto officer, and so again, we kind of push it to them, push the problem to them. One solution would be a per device symmetric key. Another solution would be to design some code that the symmetric key itself is being stored inside a TPM of some sort. And then they develop a client that basically does a handshake, transferring the symmetric key to the new device in a way that the crypto officer actually never was. It was never revealed to them what that symmetric key value was. So that's also possible.
Okay, so I think having some security considerations of this and speaking to security people about whether this works or not would be good. Yeah. One other question I have on the bottom on you. So you say you modify the old device to remove the old operator-wide key. Okay, why? It's either do that. Okay, so remember the first bullet point is go to the new device and load a new operator-wide key. Yeah.
The second thing is and maybe this is out of order, right? But the second thing I'm thinking is if you load that configuration from the old device and it has a new definition for an operator-wide key, that would overwrite the value that you just stored. So you're kind of like avoiding that overwrite. So maybe just change the order of this, load the old config, and then manually overwrite the old operator-wide key.
Or another way of expressing this would be to say when you write that old configuration, you need to strip out the old device key.
Or replace it with a new one.
Yeah.
There's different ways of saying this, but the intention is actually the same key. It's the same symmetric key. It's just encrypted with a different public key, because it's a different device, and each device is a different public. So it's actually the same symmetric key value, just encrypted differently, so the config is slightly different for that reason.
Okay.
Excellent. Any other questions about key store draft?
Yeah, I just want to know how this symmetric key is used.
The symmetric key is actually currently only being used for this purpose of encrypting other keys. In fact, like in this example, the data model up until the very last or most recent version of the draft did not have this symmetric key section. There were no symmetric keys being stored in the trust store. In the key store. The reason being that it'd be foolish to have the symmetric key value in the configuration where anybody could see it. All security properties would be lost. But now that we have the ability to encrypt the symmetric key, then it opens up the possibility that the symmetric key can be stored safely. So that's one. And then two, we can then use it to encrypt all those other keys that are being, for instance, used by SSH and TLS, et cetera. So that's how it's really being used currently. But to Hank's previous comment about extending the TLS support and TrustStore to also pre-shared keys and raw keys, I would like to have those pre-shared keys and raw keys be also encrypted with the symmetric key. So that would be the other use that I'd be thinking about. Question?
Rob Wilton Cisco again. So yes, can you go back to your open issues 1? So no, forward.
This one?
One more. And again.
Again?
Yeah.
Again? Not sure which slide you're looking for.
It was the issues, open issues.
Oh, open issues. Okay. Open issues. There we go.
That one. So I didn't get your point 2 at the bottom, the cons, is it might be better to find annotation to mark this configuration as read-only, the state as read-only. So the factory default data store is read-only by definition, and running is controlled by the client. So I didn't get that bit. What are you marking as read-only?
I'm sorry, what's the question?
So the annotation is, you're suggesting having an annotation to mark something as read-only.
Yes.
But factory default data is already, everything in there is read-only, same as operational.
Right.
So what's the annotation annotating.
Oh, okay. What's it actually doing?
Yes.
Okay. So first of all, remember factory default is kind of like startup, where it really is. It's a place where you copy and you initialize running, right?
Yes.
It's the first running effectively. So it becomes running, and then you're doing a get config on running, and that's when it'd be helpful for some people to know that this is actually a read-only value. Kind of like when you do with defaults, you're being told this is actually a default value.
Okay. So so you're saying effectively you try to write to one of those values in running, the device would reject.
That's the intention. Yes.
Yeah, I'm not sure I like that, but we can discuss offline.
Okay. Yeah. I mean, so we can just basically hard code it for this draft and not create the annotation. But I think there's an opportunity to create an annotation that could be used in other use cases as well. So we don't have to. I'm just opening it as a possibility. Let's take it on the line.
So before you go ahead, so we have a comment on Jabber from Heng saying, and yes, providing confidentiality to key material should include all key material.
Okay.
Balázs Daniel Eriksson. This annotation could be very useful for server capabilities, sometimes where you can't change them because they are capabilities really, but you want to reference them, for example, in must or refresh statements.
Okay, sure. Yeah.
Rob Wilton, but then I question whether they're running configuration. I think capability is something that still needs to be solved, but I'm not sure that's configuration. Because it's not coming from the operator, it's not coming from the client, it's coming from the device.
Well, but I think what Balázs is saying is like when ITORS first did the topology drafts, and the topology was being discovered through the data plane and populating operational, but then they wanted to have configuration that would extend parts of what was discovered, part of the topology that's discovered. They wanted to have configuration, so they wanted to refer to them. And the solution that we told them at the time was, okay, we'll kind of copy those nodes from operational and put them into running. And the intention is that when it got stored, that the device would know, oh, this is something that's already in running. I don't need to create it again. But to Balázs's point, it'd be actually helpful if they could be tagged as, and maybe it's a little bit like with origin, like tagged as, this is actually a value that came from operational, or this is actually a value that's read-only.
Exactly. I don't care if we call it running or not running. It's a value that was discovered from somewhere. In capabilities case, it's probably from the software itself. And then I can put, let's say, your configuration must use something that the device is capable of. But currently, you can't put a must between operate or config false and config true. This is a way around that.
Rob Wilton, but I wonder in that case whether you want to be getting that configuration into intended. So intended, you have more freedom to be allowed to inject like system configuration or templates and things. There is more freedom there. And that's where you're doing the validation. So I still see that the ideal for running is it's just what the operator provides. So they say this is the config file for what the device should be doing, and they have complete control over that. And then you merge it with intended, which is where I sort of see these sort of default keys coming in. The validation all works because it's actually effectively intended that's validated, and running's implicitly valid by the fact that intended is, but not updating running.
Okay, so let's flesh that out on the list. Again, this is an open issue, so it needs to be discussed on the list, and I hope to see you responding to those that chain of threads. Okay, the chair is alerting me that this is running over, but just again, we had ample time on the schedule, and the discussion is important. Nonetheless, I'll try to wrap up this last part quickly. This is the last discussion number 3 regarding the RESTconf server structure strategy. So why are we talking about this? Well, the motivation was to follow the pattern that was set by all the other client server drafts. In particular, TCP, SSH, TLS, and HTTP models. For all of them, there is a grouping that represents the configuration of just a single connection, a single TCP connection, a single SSH connection, and how you could configure that single connection. But this pattern wasn't followed in the Netconf and RESTconf models. Instead, an Uber application level grouping was provided, to support both standard and call home use cases, and for each many endpoints. So, it was almost like an application level model. It certainly wasn't a model that was representing a single connection. So the change was to move from the left, which is essentially one large data model that contains listen and call home, and inside each all the endpoints, to then on the right-hand side have, really it's the second yellow or orange line down, have a grouping, a RESTconf server grouping that represents the per connection grouping. So just what is, and see the only configuration here is certificate maps. Like and this is a server, so how does a server map the incoming TLS client certificate to a RESTconf username? And that's appropriately RESTconf. It's not a TLS thing, it's a RESTconf thing. So that would be, for instance, what could be done. But then you have the RESTconf server listen stack. So if you wanted to define the configuration for listening to a single port for incoming RESTconf connections, here is the configuration for doing that. And then there's another grouping for a call home stack. So if you wanted to define the configuration for for initiating call home connections, that would be the configuration stack for doing that. And then at the bottom, we now have our application stack, which is the combination of it all. It has both the listen and the call home sections, and inside each, the multiplicities of the two stacks we just spoke of. And in the end, the before and after, there's no change. The actual data models are the same, it's just restructured. And now we have teased out this ability to have configuration models for, the call home stack, the listen stack, and also for single connections. So the question really I think this might even be the last slide, is do we continue this approach? Currently, it's only applied to RESTconf server. I did that because, as I mentioned before, I'm implementing a RESTconf server, and I wanted this, so that's where I started. But it was, I think it's goodness, and I think we should propagate it out to, not just RESTconf server, but also RESTconf client and both Netconf client and server. Any comments about this?
Rob Wilton, I think if your opinion it should be done, then I would do it.
Perfect. Okay, so that's it. Thank you for the input. No more questions?
Yeah, so just quickly summarize the next steps that you have planned for the summary of drafts. I know one of them is the definition of whether you want to go to the INA registry, in what format it should look like. Anything else?
Yeah, okay. So I always feel guilty answering this question. Every IETF that comes up, and of course the pressure is to say, we'll get it to the last call in 2 weeks' time. And then it slides. The reality is, as I just mentioned, crypto types drafts, as we're having sector review, it needs to go to ANA. There needs to be a discussion if we can do the right thing or if we need to do a fallback thing. How long will that take to play out? I don't know. But it is the dependency of everything. Everything depends on it. So, and I think it's the long pole in the tent. Then there's the trust anchors draft, which I thought was done, but Hank just mentioned that there's a desire to extend it to support pre-share keys and raw keys, and we need it. It was an oversight. We should have done it. We'll add it. It's a little bit more work, but I think it'll take less time than it will take to get the crypto types thing resolved. And then lastly, key store, which I just presented. I think we're done. There's a couple points about open issue 1 and 2, which we need to resolve, but they look relatively minor, and definitely we should resolve sooner than crypto types. So ultimately, it comes down to how long will it take to get crypto types done, and I don't have an answer for that.
Okay. If there are no other questions, thank you.
I don't have any more questions.
Can you just make sure that you're able to Yeah, I'm trying.
Okay. I'm Balázs Lengyel from Ericsson, and I hope to speak about something more simple. Now that we have the Yang push, 3 Yang push drafts in the RFC editor phase, now I'm really starting to start up with this Yang push capabilities. New co-author Benoit was added lately. So the problem why we started all this is still that on-change notifications about data store changes, that is a feature, and yes, if the node supports it, it still doesn't mean that it will be supporting it for every single leaf and every little bit of the data store. There might be a lot of reasons why, let's say, on an in-octets counter cannot be updated on every time it changes. So we need a way to document which parts of the data store actually support this on-change capability for reporting data store changes. The draft has been updated since the last IETF. One of the comments was that different data stores, candidate, running, operational, might have different capabilities for on-change. Maybe, for example, on-change notification from intended is not that interesting. So we need a separate way to define per data store. Also, in the data model, on-change related capabilities are only needed if the device or the server actually supports the Yang push on-change feature. If it's not, then these should not even be there. So a feature was added. Time units were unified. Now it's always centiseconds like in the Yang push drafts. And I added some quite big examples to see what kind of instance data would be a result. Except for one question, I think the authors believe that this is ready for working group Rust code, but it's up to the table on the left. So what kind of Yang model do we have after these changes? One change is that we have a per data store list that defines which data nodes support or do not support on-change notifications. This has basically 2 default values, one for state and one for config. And then these capabilities are inherited down the data tree. And if you have a few exceptions, like you want to say that, yes, I support on-change for all leaves, but except the statistics branch, then you can have these few exceptions documented in some lists. Some other capabilities related to updates were also added: update period, dampening period, max objects per update. This is how it looks like. And I think it's quite stable, except yesterday there was one additional question raised, that you see that the on-change capabilities are defined per data store, and even inside data store, potentially per schema node or data node. On the other hand, these times like update period and dampening period are defined on a global level, and that was the assumption for quite some time. Now, esteemed colleague raised the question that they need a more specific definition for this one as well. I understand that sometimes, let's say, one hardware might be able to report, I don't know, every second, one other next hardware only every 5 seconds. Question is how detailed, how complicated we want to make it. My feeling is that whether you support on-change or not, yes, no capability, that's very important. And you don't get any feedback if you try to ask on-change and it's not supported. On the other hand, for these periods and maximum number of items, you do get the kind of negotiation in Yang push. We could make it per data store, per schema node, maybe per transport mechanism. and it might also change with software load. So question is, how complicated do we want to make it, or is it to have it on a global level?
Benoit Cisco. So actually, I like very much on-change flexibility, because that's right that, for example, we could have on-change on the entire data store. We could have on-change for a specific feature. We have that. Not the minimum updated period there, for example. The question is not how complex you want to have it. The question is how reliable we want to get this contract with the box, right? So if I go on a box and I want to discover what it could do, okay, there are implementation where the minimum update period is for the entire data store. Great. But there are some other as well where actually the cadence, right, that you want to get information is different on a line card, for example, for a specific interface. If you're getting information from the FIP, etc. Now, if we take like the guidelines that we want to get the contract whenever you connect to a box, it's important to understand the minimum update period for each of the different things you can get, right? Because if you want to assure your box, it's like difficult to say, okay, let me try like 10 seconds to get information. Oh, I could do more. Let me try like 8 and 5 and 3 until you get like, well, beep, you can't do it. So it might be better to get this in the contract whenever you connect to the box, telling for this part of the 3, I could get you every half a second. But for the other one, interface counters on the line card on this box, I could do 30 seconds. So if we have to rely on this to get any assurance, any closed loop automation, we need this flexibility. And I get it that it might be complex, but we might be getting the same flexibility that we've got below or the top as well.
I see it as somewhat different, because these global minimums are saying that the best the box can do in any part of the data model, any data store is, I don't know, 100 centiseconds. And then you try that for interface. Oh, interface sends you back that it's only 2 seconds I can do. And then you still have that reliability. Yes, it's a one more round trip. Yeah, you can put it in this one as well. So these minimums mean that that's the best the box can ever give you. And so maybe some parts will give you a worse value.
But maybe it's not the right question, right? It's the best the box can do to get me that information as opposed to that one. This is the question that we have to answer, right? As opposed to, because, you know, if you implement this, minimum update period will say, well, okay, 5 seconds. Why?
No,
because
you will say that
logical.
The minimum is 10 centiseconds. I'll try 10 centiseconds, and then the box will tell me that.
Okay, let's do that. 10 whatever unit. Then we'll go to some people who want to use the box, and I'll say, right, I want to get like my FIB information every half whatever unit. And then you say, oh, actually, no, Mr. Customer, because it's like more like 5 seconds is common sense. So, you know, okay. It's a question of contract and setting the right expectations or to rely on the information.
Rashad, Cisco, just to add to what Benoit was saying, I mean, in terms of implementation, you get collectors and sensors, different hardware, which have very different collection capabilities. And you already have fields per sensor path. It's not like you're adding an extra list or whatever. It's that field could be, if you put the update period per path, it could be optional. By default, it inherits what's at the top. It's not something you have to add, but for people who want to support that, it's there. So I think there's some significant benefit. Thank you.
I can live with changing the model in that way. Yeah. For me, it's new.
Rob Wilson, Cisco. I've not read the latest version of the draft. I have 2 questions. One is this information going to be available offline as like instance data?
This is a Yang model, and I very much hope that instance data will be provided, but that's really up to the vendor to decide that, yes, I provide you with instance data.
And then the second question is, in terms of these paths, if you have a device that supports many interfaces, can you wildcard those paths to say that the counters under an interface on any of these types of interfaces will have this performance, whereas without having to list every single interface?
At this point, I'm using node selector from NACM, which might be moved to the Yank types, that say the format is the instance identifier, but you can omit the keys, meaning then that means that every key value for that. So if you want to say that all interfaces, yes, you can do that with a single item. If you want to go into more specific Ethernet interfaces or fast Ethernet interfaces, such groupings, then no, then you have to do that one by one.
Okay. Thank you.
But I don't think we want to have a full regular expression language embedded here.
No, and I agree, and I think that's probably the right compromise. But I think it goes back to what Benoit was saying, is that ultimately this is a contract. I think it's a contract of what's the minimum capabilities you're willing to support, rather than necessarily the maximum. So if you say I can support a damping period of 5 seconds or whatever it happens to be, then you should effectively be able to honor that for everything.
It's a slightly different contract, the two parts. On change means I promise to support it. But these periods, either global or if we put them per data store, per node, or per whatever, you might still have a CPU overload, and then it will come back that, okay, I already have too many subscriptions configured, so your subscription will get only, I don't know, twice that dampening period, because I have 6 more subscriptions already in place. So these times, I don't think they can ever be taken as a guaranteed time.
But would you reject that subscription if it came in and you couldn't honor it?
I think that what's
that's
subscribe notification says that you reject it, and you say that, okay, try with the double the time or whatever time.
Okay.
Benoit Clay. So I want to come back to what you said, that we can't guarantee the minimum bit period. Well, actually it depends, because there are multiple ways that you could do telemetry, right? It could be strict interval, or if you wait until after the connection time. But the point is that we should do the best that we can for a device which is healthy, right? If the device is not healthy because its CPU is overloaded, etc., I mean, yes, we arrive into a situation where we should be updating those update timeout on the fly. It's not the point. The point is that I connect to a box and it's a contract. Now, I understand that you want to do this for 2 different use cases, like implementation time, right, and the runtime. I care about the runtime at discovery, right?
I agree that I'll change the model as you like, putting all these values under the lists. List is. Probably it will need to be renamed in that case. Still, I think that it's not just healthy or not healthy. If you have 1 subscription, you will get the promised values. If you have already 100 subscriptions on the device, it's still healthy, but yes, you have 100 subscriptions, and the device might know that I can't give you the lowest value I promised in design time. And I can't word that. The only wording I can put there is that this is the promised value in an ideal case, but the device still has the right to say that I can support only double the time.
Makes sense. Thank you.
Okay, so that means that on-change capable nodes list will have to be renamed to, I don't know, data store subscription node specifics or something like that. And all these update period, max objects, and minimum dampening period will go under that list. And yeah, that was an example that usually you don't need to put all this specific stuff in the instance data. You'll only have a few values. Any other?
So the question about last call, it looks like you need to make some changes first.
Yes, this model needs update, but after that, I hope it can go to last call.
So how many people, just get a sense from the room, how many people have read this version of the draft? Raise your hand. A few. Okay. And there's no really follow-up question. We're not going to actually do the last one. Just want to get a sense from the room. Did you want to do a follow-up question?
General.
Hello everyone. Hello everyone. This is Tian from Huawei, and I would like to introduce the update on the subscription to multiple stream originators this draft. And okay. Firstly, a brief introduction. We know the YARN push describe the mechanism about the pub sub, and this draft is about the distributed extension to the YARN push work, and we target for transport independent. Next. We described two use cases in our draft. One is about the router with multiple line cards, and one want directly push data from line cards to the collector. And the other is about the IoT scenario, and the IoT node can push data to the collector, and the border router does not assemble data as a broker. There was a discussion since last meeting. This about the IoT scenario, since this case requires node management protocols in addition to the push mechanism. For example, the node join, node leave, node discovery, and so on. So this I'm open. So if it is really useful or helpful to include this IoT use case in this draft, I'm open to hear the suggestions in the working group. And next. Here is the solution overview. We do not change, actually, and it described the basic mechanisms, including the subscription decomposition, the publication composition, and the subscription state change notifications. And next. We propose to extend, we propose the extensions for the publication composition because the receiver needs to know the number of component subscriptions. So we propose to add a list of publisher ID. For configured subscription, we add this to the subscription started and subscription modified notifications. And on the dynamic subscription, we add this to the established subscription and modified subscription RPCs. And we stopped here in last revision because we think this should be this draft should be transport independent. But there was suggestions in the mailing list to consider the transport configurations for multiple line cards. So we have the following two discussions. Next. So one is about the extension for the configured subscription. We suggest to add a list of channel configurations under the receiver configuration. And in this case, all the potential channels are pre-configured, and the actual publication channel are selected based on the subscription decomposition result. And here I also give an example. We borrow this from the Netconf HTTPS notification draft. We put this in a channel container. Put this configuration in the channel container. And Next page.
Kent, as a contributor, just a question. So it is a list of channels, and by channel you mean line card, for instance?
Yes.
Each line card will be a channel?
Yeah, each line card will have a
Okay.
channel. And the other one is the extension for dynamic subscription. This seems more complicated because there are several transport options. For the line cards, firstly, the line cards can run on server mode or client mode, and the connection could be dynamically set up or pre-configured. So we have two options. One is to generalize the RESTconf native draft. This is the mode. Firstly, the line cards run on the server mode, and the connections are dynamically set up. So we need the RPC to return the resource access information, and the receiver can get data from the line cards. And the second option is to consistent with the configured subscription, just like the previous example. And this mode actually, the line cards runs on the client mode, and the connection is pre-configured. So all the channels are pre-configured. Just push data when the subscription request is accepted. And next, yeah. So next, we consider to improve the examples, but we also have question what kind of example is expected, because we see we did not see a similar example in the subscribed notification draft. I think this draft can be compared with that one, but we did not find similar examples. And we also accept other suggestions on issues we need to consider in the following work. Any questions?
No questions? Okay, good.
So, Tim Carey, Nokia, we did have a question. I think I brought it up on the last time, and you asked a question again about the IoT use case, right?
Yeah.
And, my concern was that outside of a closed ecosystem, a network element itself, you would have to have some additional capabilities in place to be able to discover if it's in the network element, the line card from the I'm going to say proxy, I forget what you call it, the master guide. And so there's got to be ways to be able to do all the discovery elements in there. So if you try to extend this to anything outside of closed ecosystem, I think there's some considerations that that need to happen for the solution to work correctly and all the security that goes around it. Right. Right now, you're just constrained to a locked box, if you will. If you extend it past that, then you're going to worry about discovery and other elements. So that would be my concern with the IoT use case.
Yeah, I agree. So what's your suggestion? So you think we should not include that in the draft? Or
unless you're going to want to go into the, I think so. I think
What's
if you want to go
suggestion?
into those other use cases, you're going to have to address these different issues. And so I don't think that was your original intent with this draft, right? You were just trying to say, look, I've got a closed ecosystem that I'm going to put together a master publisher that's going to kind of coordinate that stuff instead of having different streams, right? That's effectively what this was doing, right? And so I would keep it into the context that it was in. If you do choose to make it broader, then you're going to have to address these other issues.
Okay, thanks.
So I think as a contributor, my takeaway from that would be, at a minimum, the draft needs to have a section that speaks to this and at least identifies that intention and And then there's a question of whether or not the draft actually solves it. So one potential solution might be for it to define in config files, like operational state, that list out the channels that the device is having available that subscriptions can be made on. And that would be one way to solve this. Another might be to look to the equivalent of an entity MIB, where you can somehow discover the line cards that are existing on the device, and then derive from that they might be suitable for using as channels designators. In either case, I think this draft needs to talk to it and choose an approach that that either say that it's out of scope and it's only going to support closed ecosystems, as Tim mentions, or it's in scope and point to a solution that people can use.
Right. You can imagine in IoT, if you're looking at this in IoT, it would be some of the mechanisms they use for discovery, maybe out of co-op, that type of stuff. So it can spin quickly if you want to move it out of that closed ecosystem. But even within the closed ecosystem, you're correct. You might want to give them some guidance to say, hey, look, when you build a line card, it becomes what you guys were talking about, becomes a channel, right? And you want to be able to list the capabilities.
Okay. Thank you.
Guan from Huawei. For this solution, I just mentioned we have already implemented in our some product and integrated with the customer. This. Okay.
So Kent as a contributor, I guess I think we discussed this on lists. And with the channels, and it was unclear to me if the channels was a list of channels or not. Also, there's we don't have a Yang model that is yet defining this node, this container called a channel, or actually it's a list. We don't have
a list of
we don't
channels.
have a node. We don't have a Yang model that defines a list called channel. Where is that Yang model? Presumably it should be in this draft. Well, actually, really, presumably it might have been in the subscribe notifications draft, but I think that there's I'm not really clear how to extend this draft to have that definition of the list of channels in it from the Yang modeling perspective.
Could you go to the slides that configure subscription? Yes, this size. So right now, this is not included in the Yang model in the draft. So if we can agree, we can have a consensus, then I would like to add a channel list under the receiver. Yeah.
We don't see it on the screen.
That means each receiver can have several channels. Each receiver can have several channel configurations.
Okay, again, as a contributor, and also a co-author of the HTTP Notif draft that Mahesh is going to present after your presentation.
Mm-hmm.
That HTTP Notif draft is the first Notif draft that we have that this working group has produced for a configured subscription. And the approach is taking, which is in fact was sort of suggested or almost mandated by the subscribe notifications draft, or almost RFC, was to augment the receiver node. And so that's what that draft does. It augments the receiver node.
Yeah.
And then what you're suggesting is that there'd be a channel list underneath the receiver node, and that it should actually be augmenting the channel node.
Yes.
And so how is it that it knows, am I supposed to be augmenting the receiver node, or am I supposed to be augmenting the channel node? How can it, so I think we get into this issue of, and these Notif drafts it's the intention of the Notif draft is kind of somewhat independent of the transport, the context. So how would it know if this is a device that has line cards or not, and what is the appropriate augmentation point? I think that's the issue that we need to resolve.
This is also an augment to the subnotif draft. So that means if you if you augment, if you only wanna enable the one channel to the receiver, like the subnotive draft, you just augment that draft and add your configurations on the receivers. And if you want to enable the multiple line cards, the multiple originator scenario, then you can augment the channel configurations on the channel here.
I think I understood that. And to just sort of restate it, what you're saying is that the HTTP notif draft could actually have two augments, one to receiver, one to channel, and each of those augments could be, for instance, with a feature statement, so that it's only one or the other, or maybe both. I don't know. Are enabled at the same time.
Actually, I think no need to do that, because the channel configuration is also under the receiver, right? So you just augment augment your configurations to the receiver of the subnotif draft.
But the subscribe notifications draft doesn't itself have a channels list in it, like by default. And so devices that only implement that RFC will not be having a list of channels. And
yes,
so
that is the question. Yeah, I realized this question. So initially I send an email to you to suggest your transport document to include these channel configurations. So that can be compatible if you only enable one channel or multiple channel.
Okay, so it can't. There can be many notif transports that are defined. The HTTP notif is just one of many possible. It can't, and I don't think we want each of those notif transports to themselves have to be augmenting an optionally implemented channel list. So it's not the right place to do it. I think that your draft can have a data model that augments the receiver list, adding in a channel list. Mm-hmm. Some devices will implement it, others won't. The notif drafts, we could actually have it that they have a dependency both to subscribe notifications as well as to your draft with two augments, and there's a feature effectively that the server chooses whether or not the notif is augmenting the channel list if it exists or not. I think that's what we could do. But we can't just if we move the channel list into the HTTP notif draft, then it's only one of many possible future notif drafts. It's not the right location for it.
Balázs Lengyel Ericsson. I'm confused by a statement on this list. All potential channels are pre-configured. So are these configuration data? Config true nodes?
Yes, it's configuration.
How do you prevent the user to add or remove channels that actually exist or are a dummy? We have that problem in many places and have a Ericsson specific or 3GPP specific solution, but what is your proposal?
I actually do not realize your problem. I do not understand your problem.
So I see that all channels are pre-configured. Who pre-configures them? The device itself, or?
For device.
Okay.
For device to configure all the channels.
What prevents the operator from going on and saying that there's also a Balázs channel? Actually, there's no such thing, but it looks like from now on as if it was there. So how can you prevent someone messing up this pre-configured set of channels?
Well, there's two things. There's the adding of channels that don't exist, and there's the forgetting to configure channels that do exist.
Or removing channels that were pre-configured.
Right.
I think maybe the channel is some resource, just use ref in Yang and reference that resource. Like an interface, because like a FTP, maybe we can specify the outgoing interface. We just configure the interface, but that interface must be in the interface model and just reference it, maybe like this.
Okay, but it was Yeah, that doesn't really address the problem. I think that if the operator even by mistake removes a channel, will it ever get back there, or how shall he know that he should put it back there?
You mean just configure again if he configure to remove the channel and how to get back that channel, right? Maybe we should define another table just for reader only, for maybe another channel for reference, maybe.
So we have a comment on Jabber from Eric. He says, I support Ken's proposal for multi-stream originators. In HTTPS Notif, you can augment subscribe notifications for some objects and multi-stream where multiple line cards are needed.
Thank you, Eric. Going back to the previous comment or discussion we're having, let's take a step back. Why do we want to have the list of channels at all? The reason why is because some protocols require per channel configuration. For instance, and actually it's questionable, right? But for instance, in TCP, you may want to specify the source IP address on a per line card basis. Also for TLS, you may want to specify the cryptographic credentials on a per line card basis. But those are TCP and TLS specifics. Not all notifications transports will necessarily have either or any such considerations. For instance, a flat UDP, let's say syslog over UDP, has none of these concerns. And so a global configuration of syslog over UDP, for instance, just going to receiver, augmenting receiver, and then there could be a global flag that says, I want these line cards to be able to send syslog over UDP straight out the data plane. And that's it, we're done. It's just a global flag. There's no need for a per line card configuration of any sort, right? So I think let's try to take a step back and see how much configuration needs to go in there, and can we tease out certain flags that exist at a global level versus per line card basis and whatnot. Does that make sense?
Yeah.
So in the interest of trying to move this draft forward, one conversation that the chairs were having was to figure out maybe we need to put a design team that might be helpful for the authors, and if such a design team would be formed, if people here would be interested in kind of contributing to that design team. Identify the problem, maybe define the scope of the draft, help to move it forward. That would be one way that we could suggest how you move the draft forward.
Would that be helpful?
Yeah, if there's a design team, it's very welcome.
Yeah, I mean, to be clear, the working group very much wants to adopt this draft. We think it's important work. I shouldn't say the working group. I can't speak for the work group. Chairs think it's, I think. Maybe I can say working group. We adopted UDP pub sub pre-4 because this was the use case that we were hoping that it was going to solve. But in the end, it turned out to be a UDP transport, which is actually not. So we did actually, as a working group, adopt this idea. We want it. We need to support this. So we're trying to get it over the line as quickly as possible. And we're just thinking that it might be helpful to have a design team. So would anybody be willing or to work with the author on a design team? Raise your hand. Yeah, I see some hands, so that's great. Can you, everyone who raised their hands, send a message to the author so that they can sync up with the author?
Thank you.
Oh. Okay, great. Thank you. Thank you. And we need to move to our last presentation, which is Mahesh will be providing. Oh, can you get this out first? What are you doing?
No, it's not working.
Just say next.
Okay. No, it's not working. All right. So I'm going to talk about HTTPS-based transport for subscribe notifications. So this is the case where we're talking about configured subscriptions. Next slide, please. So the motivation behind this draft, as a couple of references have been made, the subscribe notifications draft defined the container for receivers, but kind of left it up to the other drafts to actually define the transport. So this draft tries to do that. It's simple in terms of the fact that we're defining one well-known transport protocol, which is HTTPS in this case. And it's using well-known encoding support that is XML and JSON used today with Netconf and RESTconf. Next slide. All right, so the design is, of course, the ability to support multiple subscriptions to the same HTTPS receiver. And the idea is that without replicating the configuration for a receiver. The model basically augments the subscribe notifications container receiver, as you see at the bottom on the right side. And then that augmentation refers to a list of receivers, or a receiver actually in this case. And the receiver, as we say in the module, has a list of TCP, TLS, and HTTPS parameters that it uses from the module, the drafts that Kent has been presenting and is working on. So that's really the sum of the entire draft. And I know there were a couple of questions on the mailing list.
Rashad, Cisco, why is it called HTTPS and not RESTconf? Is that deliberate, or is that?
Yeah, I think it is HTTPS, meaning it doesn't have the heavy weight of the rest of the RESTconf. It's mostly HTTPS.
Okay, and okay, I might have further questions on that. Let me.
Okay. All right. No.
Robert and Cisco, any thought of using binary encoding here?
Good question. Yes, I guess there was that draft presented earlier, and Co-op is also suggesting a binary-based notification. So that's certainly something we could consider.
Kent, as a contributor, this draft actually supports both JSON and XML. And the way it does so is through the subscribe notifications draft. Already inside that data model, there's a leaf called encoding. I think it's an identity with derived types, XML and JSON. In theory, it could be extended to support binary, and then here it'd just be binary over HTTP. So this draft itself, we don't think leads to itself. It is already not. It's indicating what encoding is being used. It just inherits it from the subscribe notifications draft.
Okay, makes sense.
Okay, thanks. All right. Next slide. All right. If there are no other questions, actually, in interest of full disclosure, I and Kent, since we are co-authors on the draft, want to step back and have our AD kind of come up to ask the remaining two questions.
Ignas Bogdanas. Well, if you really insist, I can certainly read those two.
I'm sorry, can you stand at this mic?
All right.
But no, you'll be on the video and you can actually see the hands that way.
Ignas Bogdanas. Fine, I can actually read those two lines if you insist. So, again, serious question. Is the working group sees this as the work that is needed? If the community would eventually see this being deployed and used? Right. Can I see show of hands? Right, a few. So about who has read this document? All right. I think this needs to be raised into the mailing list about adoption. Please read the document and please provide your comments and feedback about that. From those hands which I see, I think it's a little bit premature to ask this question right now. So let's take this to the mailing list.
So I read the draft in detail, and it's well written. It matches well with subscribe notifications and all that, so it's all good. But one thing I was asking the RESTconf question before is, we don't actually have an HTTPS draft for dynamic subscriptions. We have Netconf and RESTconf, right? So is it just configured, or is there something else for dynamic subscriptions? That's the part I'm struggling with.
So first off, thank you, Ignis, for running those questions, and we'll take it to the mailing list. And then back to Rashad's question, which you raised before, but so with a contributor hat on. So over the course of several IETFs, we did raise and talk about this discussion, and certainly dynamic descriptions have to be RESTconf and Netconf because you're coming in over a RESTconf or Netconf connection to begin with. With configured subscriptions, is it the best choice? Like, if the device is going to proactively initiate a connection to a receiver, should that connection be a RESTconf, Netconf connection, which all that it entails, meaning it's a full configuration, operational state, etc. type connection? Do we want all of that, or we're looking for something smaller, simpler? Remember, this is being implemented on line cards, so it has to be simple. And typically, people talk about pushing notifications. Syslog, SNMP is sort of the baseline, what we're doing. So the next simplest thing that we're thinking is HTTP S, because it is fairly simple protocol, and it doesn't come with it any of the extra management overhead of the RESTconf, Netconf connection.
Okay, thanks for the explanation.
Okay.
3GPP has recently started defining a Yang solution set for a number of O&M issues, and they actually stated that they prefer a configured way of subscription, of subscribing to notifications. So I see this as important.
So we are 3 minutes ahead of time. That's great. I guess that's it. Thank you very much for coming to the session. Of course, it's lunch now. After lunch, there'll be NetMod. I believe it's in this room. NetMod session 1, and then there'll be a short break followed by NetMod session 2 in the room next door. See you then.